In this video, I go over the last problem in homework 4 about the diagramming the operation and analyze the operations that you can apply to construction operations. And with that, we do the process analysis. So let me share the screen. And that is the homework, the last homework in homework 4, construction method and management. So you can see this is the problem that I model with the real construction projects. In this case, how to transport the sands from the mining, which is in Fort Myers, Stewart mining, to Vanderbilt Beach in Naples. Scope of project, 90,000 ton or 60,000 cubic yard of sand. We also know the capacity of the salvo is 330 loose cubic yard per hour for one salvo, and the capacity for one truck is 24 tons or 16 loose cubic yard per truck. And then we also know the number of available dump trucks, 15, and know the time for a truck to enter the Stewart mining, 2 minutes. Exit the mining site, 2 minutes. And then the truck to dump at the beach is 8 minutes. Also, the hauling from the mining to the beach with the sand is 75 minutes. And then return with empty truck is 60 minutes. And for the route of the haul, if you click in here, then I can show you with the project here. Let's go down to, so you have that here is the mining there, and then the Vanderbilt Beach, as you can see there. So what is going on here is we have a 15 truck go back and forth in here that make a cycle, right? So one cycle is one truck here with the salvo, put the mining from the mining of the sand, load on the truck go through Corkscrew Road, I-75 access, and go to Vanderbilt Beach. Then at there, it will dump the sand on the beach and then return the same road with the empty truck. So you can see that make one cycle. So what the problem with us here is the from the mining to beach 75 minutes and then return 60 minutes. Everything there is the extra minutes for that to enter, to wait, etc. So from that one here, so basically I can model that wait in just graphics so that you know what's going on in here. That here a bit, right? This is Naples Beach, and this is mining. Everyone see that one? Mining. So here we have the salvo. So wheel and have a truck, right? Truck. And the salvo will put the sand on here. And why it waited? We have, remember, we have 16 of them, 15 of the truck. So sometime it waiting. The other truck is waiting here until the this truck number 1 finish. And then when it full load, it will be hauled to the beach, and that will take 75 minutes. 75 minutes, right? And then when you go here to enter, it may waiting for dump the sand for the truck, and then they exit and return to here. Let's make another color, return with empty. So we have return. So when it returned, you can see it may be truck number 2. It waiting there until number 1 done, and then when it number 1 done, so you saw it waiting here. So entering, waiting, and that also gives the time for you for the waiting time of this one. You see the truck enter the Stewart mining, 2 minutes wait, and then exit 2 minutes at dump at Vanderbilt 8 minutes. So what does that mean here? To make a dump here, it required 8 minutes to finish. Return 60 minutes. Make sense? So that you can have, and then it enter the side of the mining 2 minutes and access. But as you can see, sometimes it's not continuous. So the when waiting for the truck number 1 load, truck number 2 may be waiting there, and waiting there is same as when you order fast food. You have to wait in line until your turn, so that you can order. So let me show the situation with the video here, so that you can see what's going on. So in this case, you can see that this is assume that is the truck number 1, and we have 15 truck in this case. So truck number 1 here, they load. You can see the other truck behind there. It will be when this one done. So you see it waiting, so that we call it a stop queue online, a queue in there. Then when this one done, truck number 1 done, move out, and then you see the truck waiting there, stopping, and then they come back to here. So that you see all the lights, just like on the queue when you order something we do with the McDonald's or fast food chains process, we learn in lesson 10. So this one come in, so this is the time that they enter in, 2 minutes. And before they enter, you see that they waiting until the truck number 1 go out, so that they can get the load from the next truck in here. See that one? Okay. Everyone see that? So that is truck number 2 coming. So with that one, how we can model this? So the truck number 2 come in before waiting. So with that, we can go back to our problem solution here. So you see this either at the mining, So load with that one here, you see the salvo, in this case the excavator, load on this one, load on this. And with that load, you can see load. What do we need for load? It need a sand ready. In this case, it need the soil, right? And then it have to need the salvo ready. Otherwise, busy on the other excavator. It's not ready yet. Now it's ready. And then the truck have to be in, right? Truck in, just like this one before. You see that it moving in just a few minutes ago. You see that move in, right? So entering in. So that is the truck in, and that's still waiting, so that you can, that is a queue online. That's why it do the inventory upside down triangles. So when you have sand, when we have salvo ready or excavator ready, and when you have truck ready, then you can load, and that takes a certain minute that we can determine. And then they can access 2 minutes the site, haul from the mining to the beach 75 minutes, and then dump, given 8 minutes, return empty 60 minutes, and then enter the site 2 minutes. And when it enter, waiting for the previous truck finish the loading before they can do the position like this, do the position, so that they can load again. And you can see that is a cycle repeat over and over. That's why you see that a loop in here. Exit, haul, dump, return, enter the site, load, right? And then you dump, you have a stock of sand in here, that inventory. That's why it's upside down. All of this axis, haul, need time, and that is a task. So all it given here is set the 3 minutes for load. So enter 2 minutes, 60 minutes, 8 minutes, 75, and 2, all are given. We just want to find out the time for all the tasks, and the task model by rectangles. So in this case, we only know or want to know what is the task, the load time. And the load time, as you can see, it depends on 2 things: the capacity of the salvo or excavator in this case, and the capacity of the dump truck. So with that, you see the capacity of the excavator, it can load 320 loose cubic yard per hour. The capacity of the truck is 16 loose cubic yard per hour, so that you can divide, right, capacity, convert unit. So you need 3 minutes for finish one load, so that you can determine that 3 minutes. When everything already done with the time, so you can do the process analysis. Cycle time, add all of them, so you can see 3 for load, axis 2 minutes, haul 75 minutes, dump 8 minutes, return, empty truck 60 minutes, and then enter 2 minutes, 150 minutes. So from that we can see, okay, so each time the truck load, dump, go back 150. If we assume 8 hours per day, how many times the truck can go? So you see that 8 hours per day, and then change to minutes, 150, so 3.2. So we can assume it about 3 cycles per truck. So one day, one truck will go 3 times. And we have be able to find out what is the truck production, so that we can compare the sample production and the truck production. In this case, we have 15 of them, and each of them have 16 loose cubic yard for one truck, so 15 times 16. And each cycle, they have 150 minutes. We can convert to hours, so 150 divided by 60. So you see that for the truck production, for 15 trucks, it can have 96 loose cubic yard per hour. That is production rate. So shovel 350 loose cubic yard per hour. Trucks can carry for all the fleet of 15 trucks 96 loose cubic yard per hour. So in this case, you can see capacity of truck is less than shovel. Shovel is more productive than truck. So in that case, compared to the problem that you do in our node, right? In lesson 10. In lesson 10 here, so you see the this one. So compare, yes, you see the people that take order, person A, and the people that make a burger, person B. 3 minutes per order, this one 2 minutes per order. So it take order is faster. So the bottleneck is maker A, so you have to wait for the next one. So let's go back to the problem here. The truck does not have to wait, because that Savo always have capacity to provide sand for trucks. So from that, we can say the number of dump per day is 3 cycles for one truck, because 8 hours we already determined, and we have 15 trucks, so it will be 45 dumps per day for years. So from that, we can determine the cycle time. So cycle time is, by definition from your note, is the average time of successive dump on the Naples beach, so that it will be equal to 8 hours, 60 minutes per hour, and we have 45 dump total for one day for 15 trucks. So you can have that 10.7 minutes per dump. So every single about 11 minutes, you have a truck come in the Naples beach to dump sand, or every about 11 minutes, there a truck come into the mining to get the sand, right? And now the bottleneck, and you can see Salvo is more productive than truck. So the bottleneck, it will be truck, because lower, just like the problem in the node that you have here, the people that make a burger is lower. So the bottleneck is the burger, as you can see here, person A, idle here. So bottleneck, it will be B in this case, because this one have to idle about 1/3 time to waiting for B to done. To improve the process, you need to reduce the time to finish, to make a burger. So from that, there we can go ahead to explain the capacity, 45 dump per day. Each dump that is one truck, 16 loose cubic yard per dome. So you can see that 720 loose cubic yard per day. And the project duration, the project give us that is 60,000 loose cubic yard per day. So you can be able to find out the duration, 60,000 every day, can finish 720. So you can say 82 days. Throughput time, the truck does not have to wait. Then you have throughput time equal to the cycle time of the one truck, 150 minutes. The other problem in hamburger, making the burger, person have to wait, right? Because the order have 1/3 time idle. So your throughput time last time is 6 minutes. In this case, equal to cycle time because you don't have to wait. The truck keep going, keep moving. So that every time like that we have. So it's 150 minutes. And you see that the cycle time for one successive dump is only 11 minutes, but the throughput time is different. So don't see that the same. What is the definition of throughput time? Let's go down to here. Throughput time is the length of time spent in the process. So for this one, you see the truck, I mean the sand from this 2 years in that process, it takes one cycle of the truck, 150 minutes. The number of trucks should be increased as truck was the bottleneck. So they say the number of trucks so that they can balance between the salvo production and truck production. So in this case, you can see that the desire, so it's similar to the paving plant production, number of whole unit. So plant production divided by the production rate for each truck. So it's similar to here, as you can see, 320 for the salvo divided by 60, 20 trucks. So currently 15 trucks, but if you increase 5 trucks, the process will be balanced, more production per day, reduce the duration. What if I increase more than 20 trucks, 25, 23, it's not efficiency anymore. The bottleneck now become in the salvo. So you will not improve the production all the time. So 20 truck is the optimal one. So hope you get the idea of how to model the process and with this problem in terms of diagram, how to model tasks with the rectangles, how to model the queue, inventory, work in process with the upside down triangles, and the flow of information. It will be the dash arrows, and flow material. Just in this case, it will be a solid arrow. Good luck, everyone.